Hello dear students, welcome to Teja my YouTube channel. In this video I am going to give list of formulae for the chapter alternating current. Okay, so first of all we have the instantaneous values of current and voltage, especially this is AC, instantaneous values of AC, alternating current or alternating voltage. Do remember that. Okay, now instantaneous current is given by I is equal to I naught sin omega t, and its instantaneous voltage is V is equal to V naught sin omega t. Dear student, if you consider a sine wave here like this AC, so at a given particular incident, okay, what is the current or voltage with respect to time? Okay, so what is the current here, what is the current here, what is the current here, what is the current here? So that is given by this particular formula current, or if you want to represent voltage, you can represent it by this. So you must have studied that in theory. I am just giving the list of formula here, where I naught is maximum value of current, that is called peak current or peak value of current. In the same manner we have peak voltage or peak value of voltage. Okay, so then sin omega t, sin omega t is the angle. Okay, then mean values of AC current or voltage is given by I mean is equal to 2 by pi I naught and V mean is equal to 2 by pi V naught. So in general we can write mean value of current or voltage is equal to 2 divided by pi into what is that, peak value of current or voltage. Okay, so I will give the general formula for that also. Okay, next, where I mean is mean value of current, V mean is mean value of voltage, where I naught is peak value of current, V naught is peak value of voltage. Okay, then RMS value of current. See, IRMS is equal to I naught by root 2, that is equal to 1 divided by root 2 value is 0.707. So that is applicable for voltage also. VRMS is equal to V naught by root 2, that is equal to 0.707 V naught. Okay, then we have firm factor. Okay, the ratio of RMS value of to the average value. So firm factor of current is given by IRMS divided by I mean. So in the same manner we have a firm factor for voltage, that is VRMS divided by V mean. Here RMS value by mean value, here also RMS value by mean value. Okay, na? So that is equal to pi divided by 2 root 2. How did you get that? Let us take IRMS. See, in IRMS we have I naught by root 2, right? So that IRMS value divided by what is that, I mean value. So take this one. So if you divide these two, so you will get this firm value for voltage, firm value for current, and then for voltage. Okay, so for voltage also you will get the same value. Then relation between mean value and peak value. So these mean value, peak value and RMS values are given here. So mean value is equal to 2 by pi times peak value, and RMS value is equal to what is that, peak value divided by root 2. Let me change this one. Okay, yes, next we have what is that, AC applied to a pure resistor. If we apply AC to a pure resistor, what happens? We will get a current through resistor. How much is that? See, this is the voltage that we have applied. V is equal to V naught sin omega t is the voltage applied to a resistor. So because of that there will be what is that, current passing through this one. How much is that? That we need to calculate. That is given by I is equal to I naught sin omega t. See, V is equal to V naught sin omega t, I is equal to I naught sin omega t. Is there any phase difference between these two? No. So there is no phase difference between current and voltage. So that's why we draw what is that, phase angle difference, or we represent the phase angle difference here by using this what is this, graphs or variation of voltage or current with respect to time. So then, so what about this one? You know it, right? Phasor diagram. For board examination also it was very important for you to draw these diagrams, but these from these chapters there were no 5 mark questions given in the examination. Okay, so there was 5 mark numerical. So this is all about a AC applied to pure resistor. Then there was derivation for power of purely resistive circuit So in the derivation you get this. Okay, so the mean value, okay, instantaneous value of power is given by V is equal to V naught into I naught sin square omega t, and if you take average value for a complete cycle, you get this much, I square R, or you can consider like this. What is that? I RMS into V RMS, so that is equal to I RMS square into V, because V is equal to IR, right? If you substitute that, you will get this. Then AC applied to an inductor, AC applied to an inductor. Okay, now here the input voltage is this much, V is equal to V naught sin omega t, and the EMF generated here is given by, see, if you consider an inductor here, let me give this diagram. Okay, like this, like this. Let me take this diagram. Yes. Okay. So when you connect AC to this particular thing, what happens? There will be magnetic field generated, that is nothing but EMF, means that magnetic field maintains some what is that, electromagnetic force. That EMF is given by minus L di by dt. Okay, minus L di by dt. So from that, if you derive, you get this expression, I is equal to I naught sin omega t. So this is only for representation. Let me go back to the previous diagram that you had to draw. Okay, like this. So if you derive for current, you'll get like this. Okay, so this is input voltage and this is the current through the circuit, that is I is equal to I naught sin omega t minus pi by 2. So you can see there is a change in phase, omega t minus pi by 2. So current is lagging by an amount pi by 2, because we have minus sign, so current lags, or you can also write voltage leads current by pi by 2, or current lags. Do remember any one. So in case of resistor, so there is no phase difference. Okay, omega t, V is equal to V naught sin omega t, I is equal to I naught sin omega t. But in case of inductor, V is equal to V naught sin omega t, but I is equal to I naught sin omega t minus pi by 2. So there is change in angle. So it is represented like this. This is the phasor diagram. This is representation of waveform for voltage and current with respect to t. Okay, then here you get this I naught value is given by V by R, right? So here we don't get R, but we get XL. What is XL here? XL is called inductive reactance. Okay, inductive reactance. So XL is equal to L omega. Can we write XL is equal to L omega? Because here, yes, of course you can write, just a minute. Okay, like this. So XL is equal to L omega. What is omega? Angular frequency. So omega is equal to 2 pi f. So then this is all about this. AC applied to an inductor, V is equal to V naught sin omega t, I is equal to I naught sin omega t minus pi by 2. Then this is the waveform for voltage and current with respect to time, and this is phasor diagram. What is this? Phasor diagram. See, if you have already, as I have been telling, if you have already studied these concepts for board examination, okay, so this formula list can easily be understandable, otherwise it is very difficult. Then power in purely inductive circuit, instantaneous power is given by V is equal to V naught minus n is there, minus V naught I naught divided by 2 into sin 2 omega t. But if you take average value of power for one complete cycle when the AC applied to inductor, so average power is 0. Okay, then we have AC applied to a capacitor. AC applied to a capacitor. AC applied to a capacitor. See, when AC is applied to a capacitor, so what will be the voltage and what will be the current? See, voltage is V is equal to V naught sin omega t. No problem with that. V is equal to V naught sin omega t. V is equal to V naught sin omega t, and I is equal to I naught sin omega t plus pi by 2. Okay, then I naught is equal to V naught by 1 divided by omega c. I naught is equal to V naught divided by 1 divided by omega c, that is equal to V naught by xc. Okay, so where xc is 1 divided by omega c, omega is 2 pi f. Omega is 2 pi f. Angular frequency, that is equal to 2 pi f. So in case of xl, you have got L omega, but in case of xc, you have got c omega or omega into c. So then here there is a phase difference of pi by 2. So means current leads voltage by pi by 2, or you can write, since I have written voltage lags here, right? Voltage lags. Sorry, here I have written voltage leads in the same manner. So here voltage lags. Here current leads means voltage lags current by pi divided by 2. Pi divided by 2. So I naught is equal to V naught by 1 omega c. V naught divided by 1 divided by omega c, that is equal to xc. So then we get this very important one. Next, power in, what is that, capacitor circuit. So instantaneous power is this much. P is equal to V naught I naught divided by 2 I2 sin 2 omega t, and average power for a complete cycle is 0. Next we have AC applied to a LCR series circuit. So here I am considering inductor, capacitor as well as resistor, inductor, capacitor as well as resistor. So here Z is equal to square root of R square plus XC minus XL whole square, or you can get XL minus XC also. Whenever XL value is greater than XC, you can take XL minus XC whole square. This is called impedance. There is a derivation for this. This is 5 mark, very important question. Okay, AC applied to LCR series circuit. So from that we have got this. Then for cos tan phi, we have got this VC minus VL divided by VC minus VL divided by VR, or some you can get VL minus VC also divided by VR. So it depends on which factor is greater and which factor is smaller. Okay, then we have the resonance frequency, very important one. At resonance frequency, XC is equal to XL, isn't it? XC is equal to XL. Capacitive reactance is equal to inductive reactance. So XC is 1 divided by omega naught C, and XL is omega naught L. So omega naught square is equal to 1 divided by LC. So if we take square to the right hand side, you get omega naught is equal to 1 divided by square root of LC. So then what is omega here? Omega is 2 pi f. Omega is 2 pi f, that is equal to 1 divided by LC, and you have got this. So you have done this derivation for board examination. So derivation for, what is that, resonant frequency. Then we have quality factor. Quality factor. See, again quality factor is given by resonant frequency divided by bandwidth. Here we have the angular resonant frequency omega naught divided by omega 2 minus omega 1. So this you have got from the graph, isn't it? Which graph is that? So we will get a graph like this, variation of what is that, voltage or current with respect to angular frequency. Then you get RMS values here. Okay, so this is omega naught, this is omega 2, this is omega 1. So this omega 2 minus omega 1 is this. Okay, so just check the graph, you will get this. This is one more formula. And then for quality factor we have different formulae. So here I have written many formulae for quality factor. Q is equal to omega naught L divided by XC. What is omega L? Isn't it XL, inductive reactance, divided by R? So for this, if you substitute the value of omega naught, that is this. Omega naught value is how much? Omega naught value is this. Omega naught L is, so if you substitute the value of what is this, omega naught, this one, omega naught is equal to 1 divided by square root of LC. Okay, so that you take here. Okay, substitute that here. So from that you get this one. Then after substituting value of what is this one, omega naught, you can get this one also. Okay, you can cross check that. So that is 1 divided by omega naught C into R. What is omega naught C or omega C? XL, inductive reactance. So you get XL by R or 1 divided by XL into R. That is also possible, especially at resonant frequency. Okay, these are all the different formulae for quality factor, very important one. Then we have LC oscillations. See, first way by using this key and this battery, we charge the capacitor. We charge the capacitor to some extent, then it will get charged. This side it will be completely gets charged with positive charge. Okay, positive charge, and this will become negative charge. And when you close this key, okay, charge flows through this inductor, and there will be energy generated here also, stored in it, and again they come back, the charges will come back to the capacitor. Again this oscillation continues for over a time period. Okay, so that we need to consider. So from that you can calculate the energy stored in the capacitor is given by Q square by 2C, and energy stored in the inductor is given by of Li square or I naught square. This is the maximum value of current energy stored in what is this, inductor. This is the maximum energy. Q naught is there, maximum charge which is stored in the capacitor, that gives the maximum energy also. Then frequency of LC oscillations is given by F is equal to 1 divided by 2 pi square root of LC. Okay, then we have the concept of transformer. So the principle of transformer is mutual induction. For board examination they have given this one in previous year question papers. Then we have the formula like this, Vs. What is that? See, transformer looks like this. It consists of primary coil and secondary coil. Let me draw here neatly. This is a primary coil given to an AC source, and there will be secondary coil, primary, and then it is given to something else. Okay, connected to something else. Now primary coil, voltage across secondary coil divided by voltage across primary coil is equal to number of turns in secondary coil divided by number of turns in primary coil. This gives the turns ratio, where T is called turns ratio, and from that we will get IP divided by IS, Vs by Vp, Ns by Np, but IP by IS you will get because current is reciprocal to voltage and what is this, number of turns here. So you get this. So this is very important, and this turns ratio formula is also very important. Then efficiency of transformer is given by output power divided by input power. So these are the list of formulae from this one, alternating current. So if you like this video, please do subscribe to Tejomaya YouTube channel, Tejomaya Physics. Especially if you want to search for my channel in the YouTube, you have to type Tejomaya Physics. Suggest it to your friends also if you like this. We'll meet in the next video. Till then, take care. Bye bye. Keep learning.